right here. Okay, so then for forecasting, what do we have to specify here? We have to generate y capital plus 1 from this distribution, right? Do we have samples for beta and sigma squares? Yes, we have samples for beta and sigma squares, right? What about x capital plus 1? We have not defined x capital plus 1. Then what is it? What is it? Okay, this one is what? This one is depreciation rate at time capital plus 1. What about this? This is what? This is interest rates at time capital T, right? Do we have interest rate at time capital T? Yes, yes we do, right? Of course, we don't have the depreciation rates at time capital T plus 1, right? Because this is random, this is future value. But however, we have these independent variables at time capital T, right? So then where is it? Okay, here. This is depreciation rate, right? And this is the independent variable, and then this is full sample, right? But we took the data from 1 to n minus 1, right? Right? So this is actually capital T minus 1, is it right? This is capital T minus 1. And where is capital T? Or say x cap T plus 1. Where is it? This is x 0, right? X 0, right? And right, and comma colon, right? Colon, right? So this is the interest rates in yuan, December of 2011, right? Right. So then using the observation in December 2011, we are forecasting what? We are forecasting the depreciation rates. Right. Oh no, sorry. This is okay. This is not December 2011. This is January. Sorry, January 2012. Right. 2012. Right. Let's say N1. Right. Okay. So using the interest rate in 2012. The January 2012, we are forecasting what? We are forecasting February 2012. We have data up to only where? January 2012, and then we are forecasting February in 2012 using XT1 here, right? Okay, so then this should be used in forecasting y capital plus 1. And you know that this is not included in this function, right? So then we have to specify the this variable. Then I want to put this x underbar capital 1, right? So then we have to change this file as well, x underbar capital 1, right? So then, so here, x underbar capital 1 equals the independent variables was at time at not at, actually this is observed at time cap t, so okay, observe and observations at time cap t, and this one which will be used for forecasting y underbar cap t plus 1. Okay, that's good. So then now we have one more step here. Forecasting. Here y underbar cap t 1 equals, right? This, what's the mean? What's the mean here? X prime cap t plus 1 times beta. Okay, let's go back to this main file here. What's inside here? This is only interest rate, but here in this example, we have also the what? Intercept term. That means what? Here, x cap t plus 1 should have the constant term 1 semicolon x underbar cap t 1. I'm sorry, it should be transpose, right? So now this is what? Dimension is what? 2 by 1, right? 2 by 1. 2 by 1. And what about this? This is 3 by 1. That's right? 3 by 1. So then here. So then what's the conditional expectation? Conditional expectation is x cap t plus 1 prime times beta, right? So then here x underbar cap t plus 1 prime times beta plus here, what's the variance? Variance is a sigma square, right? Variance is sigma square. So then rand n 1, 1. Please make sure that you have rand n. Don't forget this n. Otherwise this is just uniform distribution. Okay, rand n. And here, right, this is square root sigma square sigma 2 times. Okay, right, yes, right. And then now we have to make a storage for saving the predictive samples, right? So I'll say y underbar cap t plus 1 n equals what? Zeros n comma 1. Okay, so then we're gonna save each sample for predictive draws in every iteration. I'm sorry, this should be itr comma 1 equals y cap t 1, right? Okay, and of course we have to remove the burn-in samples here and here, right? Okay, and then I want to put this as another output, so then we have two outputs, then brackets mhm and here y cap t 1m brackets, right? Okay, right, it's good, yeah, it's good, right? So then let me run this. Let's try. Oh no, we have to run this main file. We cannot run the function file. Right. Yes, looks good, right? Looks good. So these are not our interest anymore. Let me put this comments. Insert comments. Where is it? Comments. Yeah. Or Control R. Okay. Oh, sorry, I forgot to put one more output. Y T1M. Okay, and then I'm gonna run this again. Okay, so then let's take a look at the posterior predictive samples. Right button of your mouse and open YCAPT1M. Okay, then you will have this sort of the window here, and then the values are coming up. Just wait for a second. Yes, we have here, and then I want to plot the distribution of this YCAPT+1, and then of course we have to use histogram. Okay, let's take a look at. Okay, it should be coming up in a second. Yes, right, we have here. So this is our predictive distribution of one period ahead depreciation rate. Okay, here. So then the expected depreciation rate is quite close to 0. Okay, and depreciation rate can be spent between -10 to +10, right? So then after 1 month, depreciation rate should be around this interval between -10 to -10 and 10 intervals, right? Okay, so then the volatility was quite high, right? Okay, right. So then again here, then here, let me take the expected value. So then expected depreciation rate is just mean C of YCAPT_M, right? Okay. And then my interest is now I want to compute the probability that the depreciation rate is negative. It means what? What's the probability of appreciation rate in a month, right? So that means then it's not that difficult. See, okay, see, how many samples for the samples? We have 10,000. So then if you are interested in computing the negative depreciation rates, so then just count the negative values among the 10,000 posterior doors, right? So then let me show you how to do this. Okay, so then okay, negative depreciation rate, of course, Y underbar CAPT1M is negative. Okay, so then you see that there are two operations, equality and then this inequality. So then this second operation is now statement, right? This is true or false. Okay, so we have 10,000 values. Then we have 10,000 statements. Then the output of statement should be either true or false. If true, it's 1. If false, then it's 0, right? And let me show you. Okay, let me show you. Okay, let me run this. Here, then let me show you this value of negative depreciation rate. See, 1 or 0, right? 1 or 0. If 1 means what? It's negative. 0 means positive. Okay, So then we need to just count the number of ones here. How? Just make a sum, right? So then probability of negative depreciation rate is what? Sum. Oh, sorry, this one. Divided by what? Divided by just the number of positive rows. Whatever. That's just rows. What? Rows. This one. And then let's multiply 100 just to express in percentage, right? So then let's see, let me run this. Okay, what's the value of this one? Yeah, here we go. 46.98%, right? Right, so this is less than 50%, right? So then the probability of positive depreciation rate is bigger than negative depreciation rate, right? Right. So then please try this.